Finally, we have shift operators. So we have left shift operator, which is represented with this two less than symbols, and right shift operator, which is represented with this two greater than symbols. First, let's see how left shift operator works. So left shift operator is represented by this expression A left shift K. So here A is the input integer and K is also an integer which represents the number of positions we want to shift bits. Now this A left shift K, what happens with this is it takes the value of A and shifts bits by K positions to the left. One thing we have to notice, it does not change the value of A. It just takes the value of A and shifts bits by K positions. So the existing value of A will not change unless reassigned, which means unless we assign this A left shift K value back to A, the value of A will not change. We'll see an example, then it will be much more clear to you. First, let's see how left shift operator works using an example. So here we have an integer 15 represented by variable A. If you try to convert this to 2's complement binary representation, you get 0, 1, 1, 1, 1. You can find out the value or verify the value by doing this 1 into 2 power 0 plus 1 into 2 power 1 plus 1 into 2 power 2 and so on, right? We know this already. Now, when we shift the bits of value of A by one position to the left, which is A left shift 1, what happens is each one of these bits will move one position to the left, which means the first bit will move to the second position, second bit will move to the third, and so on. Now, when we do this, the first position will be vacant, right? Because the first bit has moved to second, second has moved to third. So this position is vacant. So we fill this position with a 0. Now if you try to evaluate this, you'll get 0 into 2 power 0 plus 1 into 2 power 1 plus 1 into 2 square plus so on. And here you'll get minus 0 into 2 power 5, which will be 30. Now, as you can see here, A value is 15 and we got a double value here. Is it a coincidence? No, it is not. It is actually pretty logical. As you can see here, initially this one bit has weight 2 power 0, but when it moves to the left, here it will have 2 power 1, right? Because this will be 2 power 0, this will be 2 power 1. Similarly, if you see this bit, here it has 2 power 1. When it moves to the left, it will have 2 power 2. So in that way, every bit will have the weight doubled. That's why finally, if you see this expression, you can see here we have 1 into 2 power 0, which got converted to 1 into 2 power 1. 1 into 2 power 1 got converted to 1 into 2 square, so on. So in this way, as you can see, the weight of every bit got doubled. That's why we got a double value. So when we shift bits by one position, value got doubled. Now, when we shift bits by one more position, which is nothing but A left shift 2, we can see that the weight of bits will again get doubled. So the overall value will be doubled again. So if you take a value A, if you shift bits by one position, the value will get doubled. And if you shift bits by one more position, again the value will be doubled. And if we shift by one more position, again the value will be doubled. So when we shift bits by three positions, the overall value will be A into 2 cube, isn't it? Now, if we generalize this for K positions, which is nothing but A left shift K, the value will be equal to A into 2 power K. And in Python, how do we perform this power operation? We have this double star operator, right? So 2 power K is nothing but 2 double star K. Now let's see a code demonstration for left shift operator. So let's assign a value 15 to A. Now if you try to print A left shift 1 and let's also print A left shift 3. Let's see what happens. So here when you do a left shift 1, it means the value will become A into 2 power 1. It will get doubled, right? So we expect the value to be 30 here. If we want to write a comment at the end of the line, we can put a hash and we can write the comment. In the next line, we are trying to print A left shift 3. What is the value of A? 15. And A left shift 3 means it will be A into 2 cube, right? A into 2 power K. So it will be 15 into 2 power 3, which will be 15 into 8. So we expect a value 120 here. Now let's try to run this and see the output. So as we can see, we got 30 and 120. Now let's come back to this statement. So performing a left shift k, it does not change the value of a unless reassigned. What do we mean by this? Let's try to understand. So when we create a variable a and assign value 15 to it, what actually happens? This value is stored in computer memory in the form of an integer object, and this variable a will refer to this integer object 15. Now, when we perform this a left shift 1 operation, it might give an impression that the bits of this particular object are shifted, but that's not what actually happens. Also, one point worth remembering now is that we know that integers are immutable, right? Which means once these objects are created, the value of this object can't be changed. We have discussed about this concept in one of the previous videos where we discussed immutability, isn't it? Basically, when we perform this a left shift 1 operation, let's say we are simply trying to print the value of this expression. What actually happens is Python will take this value 15, or you can say read this value, and performs 15 left shift 1 operation, which will give us a value 30. So this value will be returned here. That's why you will get an output of 30. Now this value 30 is also an integer object, right? In Python, everything is an object, right? So when we perform this a left shift 1 operation, Python reads that value 15 and it will compute 15 left shift 1 operation, and it will create a new integer object 30. But the important point we need to note here is that the value of a is not changed because a is still associated with the previous integer object 15, isn't it? So the value of a is still not changed. But if we reassign variable a by doing a is equal to a left shift 1, then what happens? Python will perform this a left shift 1 operation and it will create this integer object 30, right? And now we are assigning this value to this variable a, isn't it? So then what happens? A will refer to this new integer object 30. So in that case, we can say the value of a is changed, right? So a left shift k operation alone does not change the value of a unless reassigned. If we take this code example now, so here a has value 15, which means variable a is referring to this integer object 15. Now when we are performing this a left shift 1, here what we are trying to do is we are just trying to print the output of this operation, right? So it will not change the value of the object a is referring to. If we try to print a here and if you try to run it, you can see that value of a is still 15. And let's say that you want to change the value of a to a left shift 3, we have to reassign variable a to a left shift 3. Now if you try to print it, print of a, now let's try to run it. And now you can see the last print statement gives 120. So when we reassign, then only the value of a changes. And same is the case here when we discussed about bitwise not, for example. So here we have assigned value 20 to this variable a. So when you perform this bitwise not of a, it will not modify the existing object 20 because integer objects are immutable. So it just takes that value, computes the bitwise not of value 20, and it will create a new object based on the output of it. So in case if we want to change the value of a also to bitwise not of a, we have to reassign this variable a to bitwise not of a. So I hope that you are clear about this point now. Now let's discuss about right shift operator, which is represented by two greater than symbols. Right shift operation is exactly similar to left shift operation, but in a reverse way. So when we perform a right shift k, Python takes the value of a and shifts bits by k positions to the right. Just like how we have seen previously, performing this operation alone does not change the value of a unless reassigned. Now let's see how right shift operation works using an example. So here we have a variable a with a value 15, Now if we convert this 15 to binary, it will be 0, 1, 1, 1, 1. Now when we try to shift the bits of this value by one position, which is represented by a right shift 1, what actually happens is each one of these bits will move one position to the right. So if you see these bits from right to left, so the bit in the second position will move one position to the right. So it will come to the first position. The bit in the third position will go to the second. The bit in the fourth position will move to the third. And the bit in the last position will also move one position to the right. Now, as the bit in the last position moves to the right, the last position will be vacant, right? So here 0 will be added. Now, one more thing is that the bit in the second position goes to the first position, right? Now, the bit in the first position has nowhere to go because there is nothing to the right of it, right? This is the first position. So this bit will simply go out, which means this will be discarded. And all the remaining bits will move one position to the right. So if you compute this value after a right shift 1, so the value will be 7. Similarly, if you try to shift by one more position, which is represented by a right shift 2, again, if you try to shift bits and evaluate, you will get a value 3. Now in the left shift operation, we have seen that with each shift, the bit weights get doubled and so the value will be doubled, right? Now when it comes to right shift operation, it is exactly reverse. So what actually happens is when we shift bits by one position, the value will get floor divided by 2. And if you shift by one more position, it will again be floor divided by 2. So that's why you can see when we shift by one position, the value will be 7, which is equal to 15 floor divided by 2. And when we shift by two positions, the value will be 3, which is equal to 15 floor divided by 2 square. And the reason for this is also exactly same as what we have seen in left shift operation, but in a reverse way. So basically when we try to shift these bits by one position to the right, so the bit weight here is 2 cube. When we shift to the right, the bit weight becomes 2 square. Similarly, the bit weight 2 square has become 2 power 1, right? So in general, if you see, if the bit weight is 2 power k, when we shift by one position to the right, the value becomes 2 power k minus 1, isn't it? 2 cube becomes 2 square, 2 square becomes 2 power 1 and so on, right? So this is nothing but 2 power k floor divided by 2, isn't it? So we can say that for each shift, bit weights are halved, which is floor divided by 2. So the overall value will also get floor divided by 2 with each shift. Now if we generalize this for k positions, so a right shift k will be equivalent to a floor divided by 2 power k. So the simple thing you have to remember is when it comes to left shift operator, a left shift k will be equivalent to a into 2 power k. But when it comes to right shift operation, it will be a floor divided by 2 power k. Now let's see this code snippet about right shift operator. So let's assign a value 15 to a and let's try to print a right shift by one position. Let's also print a right shift by 2 and a right shift by 3 positions. Now a right shift 1 is nothing but 15 floor divided by 2 power 1, which is 2, correct? And this is nothing but 15 floor divided by 2 power 2, which is 4. And this one is nothing but 15 floor divided by 8, correct? So what is the value of 15 floor divided by 2? Now 2 divides 15 completely 7 times, right? That's why the value will be 7. And if you see 4 here, 4 divides 15 how many times? It divides 3 times completely, correct? 4 into 3 will give you 12 and 3 is the remainder. So it will divide 15 3 times completely. So your answer will be 3 here. Now when it comes to 8, what happens? 15 floor divided by 8. 8 divides 15 only one time, right? Because 8 into 2 is 16, which exceeds 15. So 15 floor divided by 8 will be 1. Now what happens if you also print a right shift by 4? it will be nothing but 15 float divided by 16, correct? So 16 does not divide 15 at all, right? Not even once. So its value will be 0. So let's try to run this and see the outputs. So as you can see here, we got 7, 3, 1 and 0, just like how we have calculated. And just like how we discussed before, performing this operation, this shift operation, will not change the value of A unless we reassign it. So with left shift and right shift operators, we have seen that if we take a positive integer value A, and if we perform A left shift K, the value will be equivalent to A into 2 power K. So 2 power K in Python is nothing but 2 double star K, right? This is the exponentiation operator. Similarly, when we perform A right shift K, the value will be equivalent to A float divided by 2 power K. Now, one important point we need to remember is A left shift K operation is more efficient, or we can say faster than A into 2 power K. Similarly, A right shift K operation is more efficient, or you can say faster than A float divided by 2 power K. And the reason for this is very simple. Basically, when we execute our programs, all the operations in the program are performed by the CPU, right? End of the day, Python interpreter gives the instruction to the CPU, and CPU is the one that actually performs the operation. Now, when it comes to this shift operation, be it left shift or right shift, it is a very simple operation for CPU because it just needs to shift bits by some positions. But when it comes to A into 2 power K, so first it has to perform this 2 power K. 2 power K is nothing but 2 into 2 into 2, so on, right? K times. It involves lot many multiplications, and the final value will again be multiplied with A. Even in this case, first it has to compute this 2 power K, which is a complex operation, and then it has to do A float divided by the value of 2 power K. So these operations are relatively more complex and take more CPU time compared to simply shifting the bits. Therefore, whenever we want to perform A into 2 power K or A float divided by 2 power K, we can use shift operations instead. That's all about shift operators. With that, we completed bitwise operators, and I hope you understood how these 6 bitwise operators work. I'll see you in the next video.